Good afternoon, my YouTube viewers. In this video, what we're going to discuss is confidence intervals. So confidence intervals are a fundamental concept in inferential statistics, providing a range of possible values for an unknown population parameter based on sample data. Unlike point estimates, which offer a single value as an estimate, confidence intervals account for the inherent variability in sampling and provide a measure of uncertainty associated with the estimate. So here you've got a diagram with a 95% confidence interval. So 95% of the area of the distribution is colored in, so that means 95% is taken, and 2.5% on each side is not colored in. So when you have a 95% confidence interval, then that means you want 47.5 on the left hand of the bell curve and 47.5 on the right hand of the bell curve. Confidence interval is a range of values derived from the sample data that is likely to contain the true population parameter with a specified level of confidence. The confidence level represents the probability that the confidence interval will contain the true parameter in repeated samples. Common confidence levels include 90%, 95%, and 99%. For example, a 95% confidence interval for the population mean suggests that if we were to take many random samples from the population and calculate the confidence interval for each sample, approximately 95% of these intervals would contain the true population mean. So you've got your parts of the confidence interval, you've got the confidence level, the statistic, and the margin of error. The calculation of the confidence interval depends on the type of parameter being estimated and the distribution of the sample statistic. Here are the steps to calculate a confidence interval for the population mean when the sample size is large, that is, n is greater than or equal to 30, or the population standard deviation is known. So you calculate your point estimate. So the point estimate is roughly related to the mean, and your standard deviation is roughly related to the square of the standard deviation. And then we calculate our standard error. Calculate the standard error of the sample mean. The standard error is the standard deviation of the sampling distribution of the sample mean and is given by standard error equals S divided by the square root of n. So that's your calculation for the standard error. And S, I think, is your standard deviation divided by the square root of n, and that's the number of rows in your data, number of data points. Calculate critical value. Determine the critical value corresponding to the desired confidence level. The critical value is obtained from the standard normal distribution, that's your Z distribution, and represents the number of standard errors that correspond to the specified confidence level. So critical value equals margin of error divided by the standard deviation of the statistic. Now you calculate your margin of error using the formula margin of error equals Z times sigma divided by the square root of the number of samples. Now you calculate your confidence interval. You construct the confidence interval by adding and subtracting the margin of error from the sample mean. So your confidence interval is the margin of error plus or minus the sample mean. And so that's Z times the standard deviation divided by the square root of the number of samples. So for small sample sizes, N is less than 30, or when the population standard deviation is unknown, the t-distribution is used instead of the z-distribution. And the sample standard deviation, S, is used in place of the population standard deviation, sigma. So now we're going to interpret the confidence intervals. Interpreting confidence intervals requires understanding the confidence level and the range of values provided by the interval. A confidence interval provides a range of plausible values for the unknown population parameter, taking into account the variability in sampling. For example, suppose we have a 95% confidence interval for the population mean as 45.2 and 54.8. This suggests that we are 95% confident that the true population mean lies between 45.2 and 54.8. It is important to note that this interpretation does not imply that there is a 95% probability that the true mean lies within this specific interval. Instead, it means that if we were to take many random samples and calculate confidence intervals for each, approximately 95% of those intervals would contain the true mean. So you've got the importance of confidence intervals. Confidence intervals are important for several reasons, being they quantify uncertainty, they make inferences, they're good for decision making, and they're good to compare estimates. So that pretty much concludes the confidence intervals. So the next video, we're going to be going over some practice questions concerning confidence intervals. So I hope that you decide to watch the next video as well.